Assalamualaikum. Today we are going to talk about volumetric analysis, which is a key technique in analytical chemistry. Volumetric analysis is a method that focuses on measuring the volume of a solution needed to react completely with another solution. This process helps chemists determine the exact concentration of an unknown solution. The method is commonly performed through titration. In a typical titration, we use a solution with a known concentration called the titrant and carefully add it drop by drop from a burette into a solution of unknown concentration. The point at which the reaction is completely is called the equivalent point, and it can be detected using indicator or through instrumental method. By recording the volume of titrant used, we can perform a calculation to determine the unknown concentration. This technique is widely used in various industry and laboratories, including pharmaceutical, food and beverage testing, environmental monitoring, and education due to its accuracy and simplicity. Understanding this process is crucial for any chemist, as it forms the basis of many quantitative analysis performed in the lab.
Okay, next, let me explain to you guys about the application of total acidity determination in theory. Well, total acidity is the sum of all the measurable acids in wine, like tartaric, malic, and citric acids. This acid comes from the grapes and also formed during fermentation. We measure them in grams per liter of tartaric acid. Well, why is this important? Because acidity directly affects how wine tastes, such as its freshness and also balance. It also helps prevent spoilage, cuts fermentation, ensure legal compliance, and supports quality control during wine production. The next one is the method we use to measure total acidity, that is called volumetric titration. It is based on a simple acid-base reaction where sodium hydroxide is added to neutralize the acids in wine. We use an indicator called bromothymol blue that changes color at pH 7, which is from yellow to blue. To perform the test, we add wine and the indicator to a beaker, titrate with sodium hydroxide, and watch for the color change. Then, we record the volume used to calculate the acidity. Well, this method is easy to perform as it is low cost and works well with white or light colored wines, making it ideal for routine analysis. However, it also has some drawbacks. The color change is subjective, making it less precise. It is not very suitable for red wines because their color masks the indicator, and it is hard to automate, which limits its use in larger labs.
Next part is methodology. This part we need three things to do titration, which is reagents, apparatus, and procedure to conduct the titration. For reagent, we need one sample, 0.1 molar sodium hydroxide, and phenolphthalein. For apparatus, we need burette, distilled water, 250 ml conical flask, retort stand, watt tile, and 20 ml pipette. For procedure, firstly, fill the burette with 0.1 molar sodium hydroxide solution. Next, prepare the wine sample. Pipette 10 ml of wine into a conical flask and add 10 ml of distilled water to dilute. Next, add 2 to 3 drops of phenolphthalein as indicator. After that, titrate the wine sample in the conical flask with the sodium hydroxide from the burette slowly while shaking the flask until the indicator changes color. Repeat the titration 3 times for each sample to ensure accuracy, and record the volume of sodium hydroxide used, and calculate total acidity expressed as G per liter tartaric acid. Lastly, report the final result as the average value of 3 measurements.
Let's now focus on the result obtained using the volumetric titration method to determine total acidity in wine. The data is shown here in table 1, listing 7 selected question wines, which is 3 white, 3 red, and 1 rose. Acidity values are given in grams of tartaric acid per liter, the standard way to express total acidity in wine analysis. For instance, Rugava, a white wine, had a total acidity of 4.63 grams per liter, while Lacina, a red wine, showed the highest acidity overall at 6.19 grams per liter. The rose wine, Volumetric Rose, measured at 5.36 grams per liter, placing it between the white and red wines in terms of acidity. To make the differences easier to compare, here's a bar chart showing the same result. White wines are colored in blue, red wines in red, and the rose in purple. We can see that while white wines like Castellet and Zilaka have relatively high acidity, the red wine Lacina actually exceeds them all. This illustrates an important point, which is acidity levels are not strictly tied to wine color. Grape variety, growing region, and fermentation technique all play a role. Overall, the values align with typical Croatian wine, and the titration method proved effective in revealing meaningful variation between samples. Now, let's briefly walk through the calculation used to convert titration data into acidity values. The formula for total acidity in grams per liter is acidity equals to volume of sodium hydroxide used times with the concentration of sodium hydroxide, which is 0.1 mol per liter, then times weight factor of 65 divided by the wine sample value, which is 10 milliliter. This simplifies to acidity equals to volume times weight 0.75. Using Bugava as an example, if the titration used 6.17 ml of sodium hydroxide, the calculation is 6.17 times with 0.75 equals to 4.63 gram per liter. That matches exactly with the result from our table, showing that the volumetric titration method is both precise and repeatable. This simple method provides reliable data that helps winemakers assess and control wine quality throughout production and aging.
To conclude our presentation on volumetric analysis, let's review the key points. Volumetric analysis is a highly effective and accurate method to use to determine the concentration of a solution. However, the accuracy of this method depends greatly on how well the solution are prepared. If the titrant or analyte is not prepared properly, the result can be inaccurate or inconsistent, making the process less reliable. In real-world applications, such as in wine testing, volumetric analysis has proven useful in measuring total acidity. Studies show that both white and red wines can be tested using this technique. For example, when using the potentiometric titrant method, the titrant should be added at the controlled rate 2 ml per minute to ensure reliable result. This highlights the importance of controlling experimental conditions. Finally, total acidity is an important indicator of wine quality, and having a simple and applicable method like volumetric titration make it easier to detect and maintain product standards. So overall, while this method may require careful preparation and handling, it remains a valuable tool in both research and industry due to its simplicity, flexibility, and effectiveness. That's all from us. Thank you.